Imagine this. A medical test says patient has serious disease, but in reality, they are perfectly healthy. Now flip the situation. Test says everything is fine, but patient actually has disease. Two different mistakes, both dangerous. One creates panic and other misses real problem. And these exact mistakes happen everywhere. In business, in data science, in A/B testing, and even in AI systems. Today, we are going to understand what these errors really are, why they happen, and how they impact real world decisions. Welcome back to Sheetal's Data Desk. I'm Sheetal, and in this video, we are going to cover foundation of statistics, that is hypothesis thinking, type 1 error, that is false positive, type 2 error, that is false negative, then which error is more dangerous, trade off between them, role of significance level, that is alpha, and then beta, statistical power, common mistakes, analyst mindset, and we will end this video with final takeaway. By the end, you won't just memorize definitions, you will actually understand how decisions fail. Before we understand these errors, we need to understand one simple idea first. Foundation of statistics, hypothesis thinking. Every statistical decision starts with one assumption, the null hypothesis. This usually means nothing changed, no effect exists. For example, a feature does not improve conversion, a drug has no effect, a campaign does not increase revenue. That's our starting point. Then we collect data and make a decision, reject null hypothesis or fail to reject it. And this distinction is critical. Reject means evidence suggests something is happening. Fail to reject means we don't have enough evidence. Not the same as saying nothing is happening. This is where many people get confused. No evidence of effect does not mean no effect. And because we never know truth with certainty, mistakes are unavoidable. And those mistakes come in two very specific forms. Let's start with type 1 error. This happens when you reject null hypothesis, even though it is actually true. In simple terms, you think something is happening, but it is not. This is called false positive. Let's go back to medical example. Test says you have disease, but in reality you don't. That's type 1 error. In business, you launch a feature thinking it improves performance, but it actually does nothing. You believe the signal, but it was just noise. This is why type 1 error is dangerous. It leads to false confidence, wasted resources, wrong decisions. But here's the interesting part. Avoiding this error too aggressively creates another error, type 2 error. Now let's look at type 2 error. This happens when you fail to reject null hypothesis, even though it is actually false. In simple terms, you miss something that is actually real. This is called false negative. Back to the medical example, test says you are fine, but in reality, disease is present. That is type 2 error. In business, feature actually improves conversion, but your data says no significant effect. So you ignore it. You missed real opportunity. This leads to lost growth, missed insights, underestimating impact. So now we have two types of mistakes. One where we see something that isn't there. One where we miss something that is there. But here's the key insight. So one error creates false alarm and other misses real signal. But which one is worse? This depends completely on the situation. In medical testing, type 1 error is healthy person diagnosed as sick. It gives unnecessary stress, treatment. And type 2 error is sick person declared healthy. It means disease goes untreated. Here, type 2 error is often more dangerous. In marketing or A/B testing, type 1 error means you think your campaign works. It was just waste of money. And type 2 error means you miss a winning campaign. It means you lost opportunity. Both have cost, depends on business priorities. In fraud detection, type 1 error means block a genuine transaction and type 2 error means miss a fraud. Here, type 2 error can be much more costly. So the real insight is there is no always worse error. It depends on cost, risk, and context. Here's where things get interesting. You cannot eliminate both errors. Reducing one increases the other. If you become very strict, you avoid false positives, that is type 1 error, but you miss more real effects, that is type 2 error. If you become very relaxed, you detect more real effects, but you also get more false alarms. This is the fundamental trade off, and it's controlled by something called significance level, that is alpha. But the key idea is simple. More strict means fewer false alarms, and more relaxed means fewer missed signals. So, how do statisticians control this trade off? This is where significance level comes in. Alpha, usually set as 0.05. This means you are willing to accept 5% chance of making type 1 error. In simple terms, you accept small risk of detecting something that is not real. Why? Because eliminating type 1 error completely would make it almost impossible to detect real effects. So alpha is a balance. It controls how strict your decision is. Now let's look at other side. Beta. Beta is probability of making type 2 error. In simple terms, chance that you miss real effect. And this leads to something very important, statistical power. Statistical power is ability to detect real effect. Mathematically, power equals to 1 minus beta. So, high power means less chance of missing something real. Low power means real effects can go unnoticed. Power depends on sample size, effect size, variability. And here's the key insight. One of the best ways to reduce both error is increasing sample size. But in real life, data collection is expensive. So again, it is always a trade-off. Now let's see common mistakes people make. Most people focus only on avoiding type 1 error. They say, is it statistically significant? But they ignore type 2 error, which means they miss real opportunities. This creates biased mindset, overcautious decisions, missed growth, incomplete analysis. So, what is the right way to think about this? A good analyst asks, what happens if I am wrong? Which error is more costly? What decision does this support? Because statistics is not just about correctness, it is about decision quality. And this brings us to big takeaway. Here's the big idea. Every decision under uncertainty involves risk. Type 1 error, acting when you shouldn't. Type 2 error, not acting when you should. And the real skill is balancing these risks based on context. So, instead of trying to eliminate errors, focus on managing risk. Because in real world, perfect decisions don't exist. Only better trade-offs do. In next video, we will go deeper into statistical power and how to design better experiments. Because understanding errors is just the beginning. Controlling them is where real decision making happens. If you found this video helpful, don't forget to like, share and subscribe to Shital's Data Desk. Thanks for watching and I'll see you in next video.